So we've got this expand going this direction, factor going this direction. So the first thing to understand about factoring is just the opposite. I just drugged the wrong thing. Is just the opposite of expanding. What is going on? Too many files. So these two expressions up here are the same. So I want you to draw an arrow from expand to factor and factor to expand. So my first arrow kind of started a little low. So draw one from expand to factor, another from factor to expand. They are the same thing, just opposite. So, GCF over here. What is the GCF? Greatest common factor. So, if you were to look at this expression, 10x and 45. What would you see is the greatest common factor or thing in both of them that we could divide them by? Dom? 5. So when we factor this, we divide by 5, divide by 5. That 5 becomes a multiplier to both of them, because to get back to the original, it would have to multiply to both of them. But then we say, okay, what would it have to multiply by? Well, 10x divided by 5 becomes, Jeremiah, 2x. And then the 45 divided by 5 becomes 9. The 9. And that is how it's the exact same thing as our expression that we're asked to expand. So factoring is just the exact opposite as expanding. Any questions on this process? So we are going to move quickly through this lesson. Please slow me down if I'm moving too fast. So I have an example here for you. We look at applying the distributive property here, so we would apply the -6 to the 3x and the 4. If we take this as a minus, then my 4 stays positive. Just a review on distributing, because then if we had been given this expression and been asked, what's your greatest common factor, what would the GCF be of that expression? Close. -6, because this value is negative and we like to talk about the variable term in a positive, we can take the negative out. So technically we could either use 6 or -6, but the question is which pulls out the most, like the greatest amount of information. The -6 pulls out more information from the variable term. So it's hard to decide what's like right or wrong. Both are accurate. It's just which is better. A lot of times we'll take the negative out. And then an example of factoring. So we looked at 15x and 21, and it's already on your paper, but I want you to circle it, underline it, notate it. What is your GCF for 15x and 21? And of course, with the variable term, you're only looking at the coefficient, because we can't divide a variable for both of them. So Sam's out today. Yeah, I was about to say, I don't know where she is. So Andrew, our GCF here is shown to us to be 3. So highlight or notate that somehow. That then, if you want to show the work, we divide by 3, which shows right here that we show it's 3 times and 3 times, which is why a couple problems on your homework, and this is why I wanted to get through both of these lessons yesterday, said, which of these shows the distribution? And you'd see that I had a 3 here and a 3 here, so this should turn into 3 times the quantity, or in parentheses, 5x plus 7. Because we had a 3 in both of these, we can actually pull the 3 out front and say it will multiply into both. Are any of your homework problems that you struggled with making any more sense now? Yes. No? Okay. Like terms. You should know this from 6th grade. What does it take to be a like term? And if you don't know this, it's not your fault, but you should know this. Jeremiah? So those are two different things. So which one? No. So equivalent means they're exactly the same, right? Like a square is a square. It'd have to be the same size, same everything. Similar would be a square and a bigger square. One's like the other one, but they can be different sizes or have some differences. Sean? Like terms have identical variables or lack of variable. So you have to either have identical variables or be constant. And a constant term is just your numbers, which we talked about with the constant of proportionality. It's that number that is multiplying. Can I help you, Jeremiah? Have a bit of what? No, there's no snack sharing. The only place that would be appropriate is lunch. So we've now wasted class time because you're trying to bum food off somebody else, which is rude to begin with, because if you want a snack, bring your own snack. So here I have an A term and an A term. So if you have 3 bananas and your friend has 4 bananas, can you talk about how many bananas you have together? Yeah. If you have 3 bananas and your friend has 7 apples, can you talk about how many banana apples you have together? No, that wouldn't make sense because there aren't banana apples, although it's fun to say. So you can only add terms with the same variables. Now, if either of these variables have a power, then that gets more complicated, but we're not dealing with those yet. We're not dealing with variables with powers. Jeremiah?
Well, what if it was a liquid? If it makes a liquid together?
No. You're playing the 7th grade game. We're moving on. So, factor out these expressions, parts of which have maybe been given to you. So like the first one, I gave you the common factor. The one at the bottom, I only left you to figure out the common factor. Try these. Figure out what could be divided by both of them and pulled out. So actually, let's do the first one together since it's partially given to us. So Ashley, if we divided each of these by 4, we could go ahead and show the work by saying divide by 4, divide by 4. And those, if you want to show, kind of just come right there. So what would then be left to go in my parentheses? Yeah, 2a and, what's 4 divided by 4? 1, yeah, be careful there. So this would become 2a plus 1. So this would be red. I need your attention just so you understand when I say these things. This is red 4 times the quantity, 2a plus 1. Saying the quantity kind of notates those parentheses. So when we say 4 times the quantity, that is opening up parentheses, and then we say whatever we say, and when we stop our statement, it closes the parentheses.
I think this is how you do the 3.5 and minus.
So look at those. You figure out what is common in both of these numbers.
Oh.
What's common? So that we could divide by. You're not limited to divide by numbers. You can pull variables out too. You could pull numbers and variables out if we could divide by a variable with a coefficient.
How would you do it for the time?
So you said the n is number, right? So you could pull the n, so we should divide by n, and you're not writing the work that I'm writing. So if we did divide by n, that n is what comes to the front, because I drew those arrows to show that the 4 becomes the coefficient to the parentheses. That n becomes the coefficient to the parentheses. So then m times 3.5 would give you 3.5 m. M times n would give you mn. The other minus in the middle. Oh, will I? Yes.
Yeah.
I thought you were asking about my ability.
So it's this one.
You are no, because you figured out this one. Think about what's common between y and yx. All right, let's go through these together. Elena. In my middle one here, actually, let's go here so then I can zoom in on the other one. So down here, right below the one where we had the 4 shown to us, we now see a 3.5 and an n in the quantity parentheses. What would be that common factor that was pulled out? So if we look at first term, second term, now first term, second term, what's missing? What did they pull out? The m. So I can divide by m and divide by m because that's common to both of them. Those now come together as a common factor that will distribute to both of them. And think about it. When I do m times 3.5, I'll get 3.5m. When I do m times n, I'll get mn. The minus in the middle, minus in the middle. Make more sense? So let's try. I'm going to zoom in so we can see this a little bit better. Why did you do? I don't even know how that happened.
Mr. Hudson, is m equal to 3.5?
No. M is just a variable. We have no idea what m is.
But like, it says m.
Says what?
Never mind. I see what I did.
You see what you did? So for my 14x minus 21, Noah, what's our common factor between 14 and 21? 7. So we divide by 7. Guys, please show this work that we're dividing by 7. So the 7 comes out front. My 14x divided by 7. Well, what's 14 divided by 7? And then you bring the x with you. Then, Noah, what's my final term there? A 3. So we get 7 times the quantity, 2x plus 3. Any questions? Dom.
Can we use the commutative property for this and say 3 plus 2x?
Yes, but we wouldn't normally do that because we don't want to confuse ourselves by changing the order if we don't need to. Now, if the variable had been the second term, we like the variable to be the first term in this parentheses, so you can. We just don't normally do that. Commutative. To commute means to move. Whitney, what about our common factor in y and xy?
Y.
The y is our common factor. It comes out front. So then, y divided by y becomes, will be just what? Ooh, any number, because y represents a number. Ah, yeah, any number divided by itself is 1. Then, if I have a y on top and a y on bottom, they become 1. And Whitney, I'm left with an... These became 1. What am I left with from the top? The x. So we get just x. So we get y times the quantity, 1 minus x. Questions? And not here, but Andrew.
So would 1 instead of the y in there, 1 times y minus xy, would that work? Is that
What?
y?
In here?
Yeah. No, the 1 is first, then y.
No. You can't factor out a 1. Because factoring out a 1 doesn't do anything. So if you factor out a 1, you did nothing.
Well, I did have all those numbers, but I just...
So you can't factor out a 1. It doesn't do anything. So essentially what you had here, y minus xy, was the same thing we started with. So you did nothing. You understand what I'm saying? And our final, most difficult, Jeremiah, you think you step up to it? 4. 4 can divide from the 12. 4 can divide from the 16.
Spicy.
So if we try 2, so my 12a, when I divide 12a by 2, I end up with 6a. So make sure that you put your 2 out in front. Then your 6a is your first term, plus 16b divided by 2, Jeremiah. 8b, and bring it home for us, 5c. Remember to preserve the signs between the values. Any question? Try the got it on the back. What is the factored form of that trinomial? When it has 3 different terms, it is a trinomial. My best advice, immediately do this. And here's why. The most common mistakes I see on these tests come back to the signs. People will use the wrong signs. Set up your parentheses first, then deal with the quantities, like the numbers. Anish, if I look at 12x, 42y, and 3, what's my common factor? A 3. So we can divide each of these by 3, which makes 3 my common factor. 12x divided by 3, Anish. 4x, you gotta give the variable value. 42y, since we already brought the minus over, I don't have to worry about that. Keep going, Anish.
It's 14y.
Yeah, 14y. And the 3 divided by the 3 gives me a 1. Please do not think that because it's a number divided by itself, it disappears. It cancels out to 1. Please put it away. It cancels out to 1. It doesn't disappear. So guys, I'll just make blanket statement. That goop slime stuff, not allowed in my class. It's a pointless distraction, and you guys end up not writing your notes. I felt like I had told enough people to put it away that people would have figured it out by now. So looking at this table, we need to identify terms that have, not identify, this is just showing us terms that have identical parts and terms that have not identical. So when we look here, we have x and x squared, xy, xy. Like when you have multiple variables attached together, they're kind of like their own new variable. So this xy is now your variable. Even though it's 2 variables, I can look at, yes, do they have the same thing? They do. And then, no variable at all, constants, they're like terms. Give me a second. Non-like terms, different letters, different powers. This is the one that you should really like put a star or put an arrow or something. This is where people screw up. You cannot combine an x squared with just an x. The powers are different. They are different values. This is like area, and this is like length. This is like 3 feet, and this is like 9 square feet. Space versus length. Then, multiple variables, single variable can't be combined because these variables are attached. This has no other variable attached to it. And a constant and a not constant, not like terms. Jeremiah, do you still have a question?
Yeah, is the square the 2 or the 3?
The square is the 2. So the exponent is always what's up here. This in front, what's the value in front called?
Constant.
Well, it is a constant, but it's the coefficient.
What is the 3 represented as? I know it's a...
You mean when it's like this?
Yeah, what is that one?
Cubed. This is x cubed.
Yeah,
And that would be volume. Length times width times height. So like how much volume can fit in something. So, choose which of these has like terms and combine the like terms. Then move on to the example. Actually, you know what? I'm going to give you guys 3 minutes. I bet you can finish all of this. I'm going to give you 3 minutes and we're going to use cards, see if we can just bust through the rest of this. I'm going to pass out your next steps. Yeah, you can. choose which one has like terms and combine those like terms. One of them does not have like terms and cannot be combined. Jumped out. If there's an odd amount of negatives in a multiplication or division, it will stay negative. If they have like terms. So you can reference back to here. Do these have like terms? Can they be combined? Alright, let's go ahead and bring it back together. Julian, which of these has like terms? My first expression or my second expression? The first one, because the variable is x on both of them. Here we have a variable of x and a constant term. So if I had a negative x, and then I added 3.5 x's to it, how many do I have? Well, this negative x, what number would really be in... What number would really be in front of any variable that doesn't already have a number? Well, of course the negative's there, but what number? How many x's are here? If there's 0, what? 1, right? So this is really negative 1x plus 3.5x, which when I combine those, negative 1 plus 3.5, we're at 2.5. So we get 2.5x. And these are not like.
Mr. Hudson, so is 2.5x the like term to negative x plus?
They are like terms with each other. There's no like single like term because it has to have a partner.
They should at least try to trick us. Like, they should have made it like 35 and like 6 or something like that.
Okay. I don't know exactly what you mean by like trick.
For the like term.
So when we talk about prices going up, we use this term called inflation. Inflation is when like all things increase in price just because money actually decreases in value. So, Ellie, when we look at this problem, we're talking about increasing the price of produce or fruits by 3%. So write an equivalent expression here by combining our like terms.
So what I did was I divided by p, which is constant, in both of the.
Yeah, so then you got p times what?
P times, well, p divided by p is 1.
Boom.
And that would be 0.03 or 3%. But I wrote it 0.3.
Okay, so then what do I get when I put it all together?
Putting it all together, you would get
Like, can I add inside my parentheses now?
Yeah.
So what do I get when I add that?
1.03p.
Boom! So this would be 1.03p, or 103% times the previous price. So here, where it says how the produce manager can find the price per pound of any type of fruit, we just say take that previous price and multiply it by 103%, or when we do the math, it's just 1.03 because we put it in decimal form. Same thing when all, I was going to say every, and then I switched to all. When all items go on sale the same amount. So if we have a blanket sale on the store, every single item has the same discount, and we discount things 15%. Then what percent would I really be paying if I discount everything 15%? 85%, right? So I can show that by saying B is my common factor here. This really becomes B times 1 minus 0.15, which becomes 0.85, which is really 85% times B. And if we knew the price of the bread, we could then find out the new price of the bread by just plugging in. But we don't, and that's why we use a variable. And finally, do you agree with a friend who says that when they see this sign, they just then multiply by 0.7? Sean, what do you think? Why not?
Because it's on 7%.
So he said you can find the sale price of a shirt by multiplying the original by 0.7.
Yes.
Is he looking for the amount of discount? No, he's looking for the sale price, not the original. He's saying the original price is, well, he didn't write it out, but the original price would be whatever he's multiplying by. And he says I can multiply that original price by 0.7. What does 0.7 represent?
70%.
70%, right? Not off, but what he's paying. What he's saying is he's going to pay 0.7 times, let's say, P, or, yeah, because I was going to use original price. But if P is the original price, is this true? Can I figure out a 30% discount by just multiplying by 0.7?
Yes.
Yeah, because we end up needing to pay 70% of the original price. So this is true. Your friend is correct. Any questions? All right, let's look at 7.3. We should be able to quickly work through a decent chunk of this. So let's define, let's be explicit, let's be as clear as possible. What is a constant term? Honestly?
It's always the same.
Yeah, but like we need more. Because like x could be x is x. And if I say x will never change, does that make it a constant?
No.
Correct. That's why I'm trying to push you to give some more detail with your definition. Andrew? Sorry.
Constant is a number without a variable, and it's usually just a number, just a regular number. It's nothing without. Doesn't have a coefficient. It's not a coefficient.
Ooh, a constant can be a coefficient.
Huh?
It can be a coefficient,
Of itself.
but then it's attached to a variable. So if we're going to paraphrase this down, Dom, give it one last shot.
Okay, well, isn't it constant? It stays like the same throughout all problems.
Yeah. But again, like I could say x will stay the same.
Same value.
Go away. A lot of people, I can't believe how many random calls I'm getting these days. A constant term is a known value. So a variable like x, y, z, do you know what that is? No. That's why we represent it with a letter. So it's a known value that cannot change or that will not change. Yeah?
So a variable term is an unknown value that always changes.
An unknown value yet to be determined, or like an unknown. Really, we can just say an unknown value represented by a letter. running out of space here. And a coefficient.
The number next to it.
How does it have to be attached?
To multiplication.
Yeah. So a coefficient is the number. I realize that when I write in cursive, some of you guys get confused. A number attached to a variable by multiplication. And this can be a fraction. It can be a decimal. It can be a whole number. It doesn't matter. It can be negative. It can be positive. It's just the number attached to the variable by multiplication. So, almost always, somebody's like, well, can 0 be the coefficient? Well, if you have 0 of something, do you have that thing? No, and 0 is not really a number. It's the lack of a number. So that's where we get in this argument of, is 0 a number? Well, we count it, but it's not really a number. It's the lack of quantity. It is count, like, you start counting 0, 1, like, or -3, -2, 1, 0, 1. Like, people say it, we use it, but it's not really a number. That's the, like, it's hard to understand. Right, but if you're going from the negatives to positives, or like on the number line, it exists, like it's on the number line, right? So we could argue if it's on the number line, it's a number. Well, it represents no numbers.
That's like saying the origin.
It's the origin of the number line. All right, so we have two terms here. This makes this. I kind of gave you a clue on the last set of notes, except it had 3, so we called it a trie. Now that this one has 2, it's a bi, but it's a bi what? Not funny. Yeah, I have good ears. Numbers. So it is a binomial. Anything with 2 terms is a binomial. This root changes as you need it to. So then, when we come down here, this is a trinomial. Right here, my third one. So if you want to notate that.
So what's the fraction then?
The fraction? What do you mean the fraction?
So would that be like what nomial would that be?
Well, if you only have one of something, what's that prefix? Yeah, not a unicycle. What if you have, crap, I'm trying to think of anything else that uses this. Monomial. So this would be a monomial or a monomial. I know, that's why we normally just say it's a term. Yeah, it's a term. It is 3/4 S. Once I have 2 terms or 3 terms or 4, like then I start to use binomial, trinomial. Like value. Not certain. You can look it up. So, in our first expression here, Colin, how many terms do we have?
We have 4.
In my first expression here? Yeah, we have 2 terms. We have the 12a and we have the 3. They're held together through subtraction. What is my coefficient, Colin?
Your coefficient is 12.
Ooh, just 12. Remember, the coefficient's only the number in front of the variable. The a is the variable, and it doesn't ask me for the variable. And what's the constant here?
The constant is 3.
Actually, we're going to say the constant is a -3 because, I know it's tricky, this would actually write out 12a plus -3. We've just simplified it. See, that's the danger. Yeah, so previously, what's the discrepancy?
Wait, I thought 12a, because they're connected by multiplication, wouldn't that be? Oh, wait.
The coefficient is only the multiplier. It's only the number. So, in my second expression here, Acadia, how many terms? 3. We have multiple coefficients. What are they?
You have 0.2 and 8.1.
Ooh, there's another one. Yeah, there would be actually a negative 1. Because remember, this would be 0.2x plus negative 1y plus 8.1z. There's no such thing as subtraction. If you really want to get technical, there's no such thing as subtraction. It was invented to represent adding negative values or adding loss. So we're really adding a negative 1y. Julian, can you pull your arms out, man? If you're cold, bring a jacket. Jeremiah?
I was gonna say, can the exponent have a variable?
Yes, but we won't use anything like that. We won't get that complicated. And do I have any constants here, Acadia? Because it's attached to a variable, the negative 1 itself would be a constant, but because it's attached up here, this term is a variable term. So we have an x variable term, a y variable term, a z variable term, no constants. So we would put this symbol, which means the empty set. It means nada, zip, zilch, nothing, does not exist. Sorry for trying, you lose, nothing's there. Sure.
Okay, the 3 terms.
Thank you for correcting. There are 3 terms.
The coefficients are 9 and 6.
We would actually say negative 6. Because remember, this would be like plus the minus.
Oh, yeah. Okay, so 9 and negative 6, and the constant would be 7.
Yep.
Wait, wouldn't there also be 1?
No, because this is not like so. This 6 says that there's 6 m's and 6 n's.
Oh.
So this is MMM, MMM, NNN, NNN. Is what this like? Yeah, that's what that is. So thank you for asking. That was a great question because I didn't really identify that. And then here, class, how many terms? 1. What's the coefficient?
3/4.
What's the constant?
Nothing.
Nothing. Thank you guys. We will pick up on the back tomorrow. Oh, sorry. Do the got it really quick. Don't leave. I do technically have a minute.
Always that technically.
So, Samantha sick. Dom,
What did I do?
how many terms?
Oh, okay. 4.
4 different terms. What are my coefficients?
Your coefficients are 6, 7, 9.
Negative
Or
7.
negative 7. What?
And my constants?
Negative 4.
Negative 4. Thank you guys very much.
Thank you.
Have a wunderbar day. Means wonderful.